Hello everyone. Welcome to another Wave to Wave webinar and thank you for joining us today. We invite you to review our entire webinar lineup for a full appreciation of the beneficial impacts of robotic fiber switching in various Layer 0 deployment scenarios. Today, we will focus on data centers and their strategic ecosystem directions in satisfying the rapid demands of growth and speed of services delivery. Management of data center Layer 0 cabling infrastructure becomes more important every year due to increasing dependencies on moving ever-growing quantities of data. Capacity, speed, and reliability are critical to data centers, and infrastructures must be sufficiently robust and manageable to carry higher traffic volumes and enable increases in data center densities. By building sound Layer 0 infrastructures that support higher layers of flexible resource allocation, we will show in this session that businesses can transform and scale continuously with greater agility. Next slide, please. We will start with an overview of industry dynamics and some key challenges for data centers, regardless of size. In fact, we will show that as data centers scale, common problems become even more acute. This is followed by a summary of data center costs and key ecosystem factors affecting these costs. Once we understand key components of the data center cost structure, we will briefly look at Layer 0 infrastructure impacts on these costs. We will also touch on data center architectures and specifically zero in on defining distribution areas and how these different architectural distribution areas affect different deployment architectures and scenarios. Once we have reviewed data center zoning and distribution areas, we will look at various ways robotic fiber cross-connects become a critical value-add ecosystem component within data centers. So let's get started. Today's data centers are undergoing rapid growth that is driven by a number of game-changing factors. In fact, the entire data center environment is moving towards software-based virtualization and automation. This type of applications-driven network OAM and P automation is currently referred to as software-defined. The use of fiber optic technologies throughout data centers has taken off in recent years. Fiber optics is the best medium to support very high bandwidth speeds, while also providing longer runs with lighter cable weights, resisting electromagnetic interference, and also deters hacking. Even horizontal cabling within the data center is increasingly fiber optic. The accelerated technology developments in fiber technologies, such as silicon photonics for interchip communications and advanced robotic fiber cross-connect products, is fundamentally changing the entire data center ecosystem. In addition, the adoption of network switching architectures such as spine and leaf are driving the scale of the network, requiring a greater fiber count Layer 0 cabling infrastructure. We see these data center dynamics in various forms, regardless of data center type and across different industry sectors. Next slide, please. The various types of data centers include micro data centers, which have on the order of tens of thousands of servers, used primarily as nodes and content distribution networks and applications such as email. Mega data centers, which are cloud service data centers, having on the order of tens of thousands or more servers supporting massive data analysis, huge amounts of fast RAM, massive numbers of CPU cycles, or massive disk I/O bandwidth. Enterprise-oriented data centers, which are DCs optimized for a single company. However, some enterprises also have very large data center operations, such as major financial institutions. Distributed data centers, which are larger than micro data centers, but still distributed for various reasons, such as security, load balancing, or disaster planning. Colocation data centers, which contain carrier circuits to connect to carriers at an entrance facility cage or other colocation customers without going outside the facility on service provider links. Finally, communications network operators data centers, which are traditional telco COs being transformed into data centers to ride the IT technology wave, including mobile cloud RAN data centers and fixed landline central offices utilizing core principles. These data centers have varying degree of challenges pertaining to Layer 0 infrastructures. Next slide, please. As shown in the table, many of the challenges the designer will face pertain to the data center Layer 0 network infrastructure. If these challenges are not addressed early in the data center planning process, the likely result is degraded performance and reduced longevity of the data center. Today's data center layer 0 infrastructure must be designed to offer a competitive advantage and a lower cost of ownership. As a result, the evolution path to higher speeds such as 40 gig and 100 gig data rates, as well as next generation applications such as cloud computing and virtualization, must be ensured early in the data center layer 0 cabling infrastructure design and planning process. In addition, increased efficiency is becoming more and more important as data-intense applications come online. With this, data center rack space, cable pathways, cooling, installation, maintenance, and risk avoidance become increasingly important considerations when planning and designing the data center. While many of these infrastructure-related challenges will have an impact on the performance of the data center network, proper product selection can bring a positive impact. Since the layer 0 infrastructure represents a fraction of data center costs, some designers may adopt the view that there are more important decisions to consider than which layer 0 infrastructure products to choose. Next slide, please. This table provides a rough guide to data center associated costs. Costs are normalized to a monthly bill by taking a consumable such as power and billing it monthly by consumption, and taking capital expenses such as servers, networking or data center layer 0 infrastructure, and amortizing it over their useful lifetime using a 5% cost of capital and again billing monthly. By amortizing and normalizing, we get a common cost run rate metric that can apply to both one-time purchases for servers and ongoing expenses for power. This approach allows us to view typically non-comparable costs together. A reason data center designers erroneously do not focus on layer 0 is that servers represent 45% of costs, while electricity and power represent another combined 40%. However, when total cost of ownership is considered from the point of view of effectiveness and efficiencies, the single largest cost driver of total cost of ownership is the unabsorbed overhead cost of underutilized layer 0 infrastructure. Therefore, while layer 0 networking is not the largest cost category, it and its innovative impacts are key to reducing costs and getting the most out of each dollar invested within the data center based on a number of layer 0 factors. Next slide, please. In addition to bandwidth and depreciation schedules, there are several factors to consider when determining the layer 0 infrastructure components, such as time the end user will occupy a facility, the expected install lifetime of the cabling plant, or types of applications that will run on the cabling plant over its useful life, or time frame during which standards, applications, and electronics manufacturers will support the cabling plant, the cost of active electronics, warranty length and covered components, and price as it relates to performance. Designing the layer 0 infrastructure requires consideration of many factors, including architectural and physical planning of white spaces and data center operations and design areas. Next slide, please. A typical three-tier data center architecture consists of core switches located in the main distribution area, aggregation switches located in the horizontal distribution area, and access switches located in the equipment distribution area. This so-called fat tree architecture consists of interconnection spine switches placed in the MDA and access leaf switches placed in the HDA or EDA, and each connect to every interconnection switch in a mesh connectivity network, typically via optical fiber. Data center administrators and engineers are looking to reduce space and power consumption while increasing flexibility and control. This requires newer, more agile layer 0 architectures and cabling. The ultimate objective is to allow optical fiber cabling to be used for a number of purposes without multiple moves, adds, and changes. Next slide, please. The MDA is cabled to the HDA in each data hall or point of distribution called a pod. The HDA, also known as the aggregation point, then fans out to each EDA for direct server or storage connectivity. The HDA typically is the end of row or middle of row network equipment rack. The EDA typically is the top of rack patch panel or a top of rack networking device. In addition, the logistics of deploying and managing dedicated point-to-point optical fiber cable is not considered feasible without multiple flexibility cross-connect points. That's because data centers need to scale, and low latency automated fiber cross-connect solutions better utilize the strengths of IT equipment and is ideal to position today's data centers for tomorrow's needs. The resulting order of magnitude efficiency gains translate into OpEx savings, faster service time to revenue, and lower energy costs. This brings us to a discussion on optical cross-connect technology and deployment architectures that minimize expenses while simultaneously offering maximum flexibility. Next slide, please. Some data center managers also prefer to deploy traditional structured cabling for switch-to-switch connections with cross-connects at the interconnection switch and/or access switch for manageability, flexibility, and/or keeping switches separate and secure. Cross-connects can be deployed in fat tree architectures for these reasons. This architecture is ideal for larger data centers. When fiber is distributed to multiple zones, the use of optical cross-connects allow one-time deployment of fixed high fiber count cabling from the MDA cross-connect to the IDA HDA cross-connect. For example, by inserting wave-to-waves Roam robotic optical cross-connect products into existing data center architectures, operators can simplify layer 0 infrastructures, reduce operational costs, and improve redundancy and resiliency. Structured cabling allows for an any-to-all approach within the zone, whereby any switch port can be connected to any server port within the zone. Another benefit to using structured cabling with a robotic optical cross-connect is the access switches in the HDA can remain separate and secure. The robotic optical cross-connect can reside in a separate cabinet, so there is no need to access the switch cabinet. Next slide, please. The limitations of the traditional three-tier architecture have many data centers moving to flattened switch architectures. This enables dynamic east-west traffic where it is needed, eliminating the need for communications between two servers to travel north-south through multiple switch layers. So the increased adoption of optical cross-connects is driven in part by the adoption of network architectures such as spine and leaf. These architectures are driving the scale of the fiber cabling infrastructure, requiring greater fiber counts. For spine and leaf architectures, each leaf switch in the network connects using a mesh to every spine switch in the network. As this architecture is deployed in data centers, fiber counts multiply very quickly when compared with traditional three-layer distribution architectures. The only sure way to manage the exponential growth in fiber counts is by using an automated fiber cross-connect inserted as an ecosystem component of a data center pod within a deployment architecture, creating a flexi-pod deployment approach. Next slide, please. With a flexi-pod approach, structured cabling lends itself well to software-defined infrastructures where data traffic flow is controlled from centralized control. With structured cabling, SDI is easily implemented without the need to reconfigure the entire layer 0 cabling infrastructure. Incorporating an automated optical cross-connect enables instant delivery and provisioning of any-to-any physical fiber connections, and automation provides the ability to virtualize these connections via software. An automated connectivity fabric makes data center layer 0 networks dynamically reconfigurable with security, speed, and accuracy that traditional manual processes cannot match. This on-demand connectivity opens the door to a broad range of new applications within the data center ecosystem. This functionality is currently available today from next-generation products such as Wave-to-Wave's Roam product family. Next slide, please. Increasing data center fiber counts require enhanced layer 0 management capabilities to keep pace. The architecture shown here is an approach to guard against future issues. The red lines represent fiber connections and all arrive into a central automated cross-connect area. This allows any piece of equipment requiring a fiber connection to be connected to any other fiber-based equipment port. For instance, if a cabinet has a switch that requires a fiber connection for a storage area network on day 1, but needs to be changed to a different fiber switch connection at a later date, all that is required to connect the two ports is a software command at the central robotic cross-connect area. In this scenario, a cross-connect area can also be located at the end of row or middle of row position to serve the equipment in that zone, or an HDA can serve multiple rows of cabinets in larger zones. Its purpose is to provide network administrators ultimate flexibility of the optical fiber infrastructure layer so as to better utilize layer 1 and higher equipment assets. By adding programmable fiber cross-connects, unused switched and server ports are kept to a minimum since equipment is purchased and installed based on the number of server ports that require connections rather than on the number of cabinets. Next slide, please. In summary, the use of fiber optic cable throughout data centers is increasing as companies move to even higher densities. While the ability to keep cable channels in check reduce power consumption, layer 0 infrastructures using robotic optical cross-connects also reduce power needs. Robotic optical cross-connects deployed in layer 0 architectures can help decrease power needs by keeping unused layer 1 and above equipment ports to a minimum. By building sound layer 0 infrastructures that support flexible resource allocation, designers can help businesses transform and scale continuously with greater agility. Sound layer 0 fiber infrastructure management practices also help data centers function smoothly and reliably. Robotic optical cross-connects, such as Wave2Wave's Roam line of products, allow any-to-any connectivity. So in closing, we want to extend a heartfelt thank you for joining us today and look forward to seeing you on another Wave2Wave webinar in our series. And please, feel free to send any questions you may have to info@wave2wave.com. Have a great day and see you soon.